Have you ever wondered what Docker actually is? You've probably heard about it containers, images, and all these things, but probably didn't fully understand it. So do not worry, today we're explaining Dockers through food. Imagine you own a restaurant chain. You've got a few locations in different cities and you want to open a new one. Instead of building every kitchen from scratch, you prepare a fully equipped cooking station with a stove, fridge, tools, pack it into a shipping container, and send it directly to your new restaurant. When it arrives, your team just plugs it and they can start cooking immediately. Everything works exactly the same way, no matter where it's shipped. That's exactly what Docker does, but for software. It takes your code, the libraries, your setup, packs them all together into a container, and makes sure it runs identically anywhere on your laptop, or on your colleague's computer, or even on your lab computer. Before you can use Docker's ready to go kitchens, we need to install Docker itself, the service that does this shipping of your kitchens. Think of it like signing up your restaurant for a service that builds and ships custom made kitchen containers. After doing that, by default, only the head chef or the root user can actually access Docker. So if you want also to be able to cook without asking permissions every time, so without doing sudo every time, you have to add yourself to the authorized kitchen staff with this command. Then another important thing to take into account is that every time your cooking team shuts down the restaurant at night, your ready to use kitchen container will also shut down. It will not automatically start the next morning. To do that, to make sure that the container is always up and running when the day begins, you need to enable it to start automatically with this command. And now your restaurant is ready for business. Now let's say you want to create your own custom kitchen station. You want it to include the exact stove, tools, and ingredients you prefer, and have it ready to ship to any restaurant in your chain. To do that, you write up a set of instructions, called a Docker file, that describe exactly what your kitchen should contain and how it should be assembled from scratch. Then you hand it over for the company's service and ask them to build it using Docker Build. And there it is, your very own ready to go kitchen container. You don't need to build a container yourself. There's no problem. Docker has a catalog full of pre made containers. So you can search for what you need with Docker search. And then once you find the one you want, you just let the company know that you'd like that option. AKA, we'll pull the image. So we do Docker pull and the name of the image of the container. And that's done. You have your new Docker container ready to go. And if you want to check which other containers or kitchens you already have installed, you can just do Docker images. Now that your kitchen is ready, whether you build it yourself or you got it from a catalog, it's time to start cooking. If you want to step inside a kitchen yourself, to do all the shopping, the stirring, and test all the things, you need to enter in interactive mode with option -IT, run -IT. Like this, you're inside a container working directly in that environment, and everything happens there. At some point, if you want to go do another thing like checking your other local files or opening your browser, you have to go outside the container first. Now, say that you have some special ingredients that didn't come with the container, like, for example, your secret tomato sauce or a custom dough mix. This is your local data. If you want to use them inside a container, then you have to carry them with you, and this means mounting. For this, use the option -V, followed by the path to your local computer, two dots, and then the path in the Docker environment in your kitchen container. Like this, your local files will be available inside the container, in this case under /data. Since you are in interactive mode and you're already inside the container, if you want to run some specific tasks like preparing some pasta, or if you want to run a specific script that you have there, you can just call this task directly. So, for example, in the case of a script in Python, you would just do Python and then the name of the script. If you already tested your container and you confirm that it works, you don't need to step into the container again. You can directly order it to do something from the outside. So you don't need to be in this interactive mode. You can just run it without this -it option. And you can pass the option -v if you want to use your own data like above, or not if you don't need it. This is like standing not inside a container, but just close by in the kitchen. So you can watch and hear everything your chefs are doing inside that container. So you can see all the logs, the outputs right in your terminal. And this is called attached mode. If you prefer, you can also run it quietly in the background. And like this, your terminal is free to do other things. This is called detached mode. And to do this, you have to use the option -d. And then, if you want to run a specific task, like running a function, but you're outside your kitchen container, like just now, you have to pass this command to launch your container and add in front the script that you want to run, like in this case. Okay, let's practice then. I already have my Linux machine here, and the first thing we'll do is indeed install Docker. To do this, we'll first update our apt package manager so that we are sure that we have all the latest updates on softwares. So we do sudo apt update. Okay, and now we'll install two other small tools, which is CA certificates, which will let the system trust secured websites, and curl, which will allow us to download files. So we'll go ahead and do that. Sudo apt install CA certificate and curl. Okay. And now we will create a folder where apt will actually keep trusted keys and where we'll use it to put the key from Docker as well. So we do this with a command line that I will just copy to make sure that I'm not making any mistake. Okay, so this is the folder where the keys will be saved. And now we'll download the official Docker security key into this folder. And to do that, we'll just use this command line. So we are using sudo curl to take it from this website, and then we'll save it in this folder that we just created. Okay. Now we'll just make this key actually readable, and for doing this, we'll use this other command line. All of these command lines are, you can find them online, but I will also leave them in the description of the video. Okay, so now we just need to add the official Docker repository to the apt system. So we just need to tell them apt where, if we want to use Docker, where to download Docker from. And to do this also, this is a set of lines that I will just copy. So basically we have to do this. Okay, and now finally we'll be able to download and install Docker. So we'll do sudo apt install, and we'll put docker ce, docker c cle, .io. So all this will be needed to use Docker. Build X. Compose plugin. Okay. So now we'll just install all of this, which will take a while. Okay, actually it was quite fast. So now if you want to see that Docker is well installed, we'll use this command sudo system ctl status docker, and here we can see that the status is active, so it's running, and we can also see that it's enabled, so both of these things are on. Okay, so now we can also run one of the images that Docker already provides, which is docker hello world. So to do this, we just do sudo docker run hello world as an example. So it's saying that we cannot find it locally. So then it just went and retrieved it from the libraries, and it ran it, and we can see it here, hello from Docker, and a lot of other information regarding the Docker. So as you notice, to do this, we actually had to do sudo docker run hello world. If you remove the sudo, we'll actually have an error saying that permission denied, because we are not part of the allowed users to run Docker. So to do this, we need to add us in this group. So we'll do sudo user mod -ag docker and then user. So technically now we are already in the list of users that are allowed to run Docker without the sudo, but we have to log out and log in again. Okay, so I already logged out and logged in again. Let's see if we can run hello world without sudo, and we can. It ran already without a problem. Now, the other thing that was important to take into account was that every time you restart your machine, Docker might not automatically might automatically be active. And to do this, we need to enable it to automatically turn on every time you restart your machine. So first we can already check if that's our case or not. So we can do system ctl is enabled docker.service, and we can see that it's already enabled. But if it was saying disabled, we can just simply turn it on by doing sudo systemctl enable and then docker service. So now if we go check again the status where it is currently now, it's enabled, even though it was already before. But this is how you would do it. Okay, another thing that is important, that could be important to check, is the version of the Docker. So you can just go here, click, and write Docker version, and we'll find a lot of information regarding what you just installed. Okay, now let's say we want to use Docker to run a given container. So now as an example, we'll use Python, the container of Python. So to do this, first we need to search in the catalog which options we have. So we write docker search Python. We already see a lot of options of containers that exist. Some of them are from specific users. We can see here their names. And the official version is the first one. Now, if we want to use one of them, we have to do pull of one of these images. So we'll do docker pull Python, and it will automatically pull the official first version. So now it's downloading it so that we have it also on our own machines, and this might take a while. Okay, so after your download is complete, we can use it. So first we'll check that is actually installed. So for this we'll do docker images, and we can see that we have two images installed. The hello world, which we use just as an example, and Python, which we just installed, and is the latest version of Python. Okay, so the first option to use a container will be to use it in an interactive mode. So we'll be stepping inside a container, and to do this we do docker run and we put the flag -it. And obviously in front of it we write the container name. So in this case Python latest. So now we are inside a container. We can see that it behaves exactly like Python with all what usually appears in a Python using Python. We have here the prompt where we can already run some commands in Python. So for example, one thing that we could do as just simply is just to write some print. And we can see that it works very well, and we can see the printed message. Okay, so this is interesting, but ideally we would like to run some script or some function that you just created. And for this, we'll actually step outside the container and we'll create a function that then will like to run inside a container. So I'll just create a function called myscript.py in Python. Okay, and I will just make a function that actually writes a document text file. So open, we'll call the text file I. Okay, and then we'll just write something in the file, which could be inside the container. Okay, and this is our function. We saved it and we have it here on our folder. So now we want to run this function inside a container. So we go, if we just do this, we go inside a container, but we are not bringing our data with us. To do this, we have to mount the data inside a container with the -v option. So we put -v, and then first we put the path where our data is, which in this case, this function is in the path home Rita. Then we put 2 dots, and then the path where in the container we want it to be. And I want it to be under data. Okay, then we just call the container name, and we'll write bash at the end so that we enter in the container with a bash option. So we do this, and we can see that now actually we have this bash prompt. We can see where we are. We have all these folders inside the container, and we said that our data was mounted here under the name, under the folder data. So we can go there, and we do see our script there, right? So if we want to run this script now inside a container, we simply just run it with Python. So we call Python myscript. It just ran, and we can see that it created this file I. And we can even see the content of the file that we just created, which was hello from inside the container, which was what we asked him to do. So this is how we can run a script from inside the container. Now, another option to run a given script or to use the container is to do it from outside. So we don't need to be in this interactive mode. We can just tell the container to run whatever we want from the outside. So to do this, we will remove this -it option. Then we can still pass the data if we want the data to be inside a container. And then if we just run this, nothing happens because we didn't ask him to do anything in particular. We just asked him to open bash. But we can ask him to run our script like we did before. So as if you remember, my script is called my script. I'll just remove this previously generated text file. Okay, and now to run this script again, instead of bash, we'll do what we did before. We'll call Python, and then my script will be inside the container in the folder data, right? So I want it to run Python data and my script. Now, if we do this, nothing was generated. Why? Because here in this case, we created a very simple script just for illustration purposes, and the script is just creating a file wherever it is being run. So it's not actually generating a file where necessarily we want it, because we didn't provide a full path to this I text file. So to do that, if we want the file generated to be here as well where the script is, we can just tell him that our working directory is actually data. And like that, it will run my script in the data folder, which is the one that we mounted to the container. So then we'll actually have this file here outside the container as well. So now, if we see what is inside my local folder, we can see the file that we generated by running this script in the container, this line of code inside the container, but without stepping there.
I hope you liked it and thank you for watching.